Hello and welcome back. In this episode we're going to be taking a look at the UnconstrainedBox widget. The UnconstrainedBox widget allows you to remove the constraints from any of the parents in the widget tree. You'll notice the home page contains a scaffold with an app bar, and what we're going to do inside the body of the scaffold is create a container. We are going to make it red. And then, for the purposes of this demonstration, we're going to give it a fixed width of 100 and a fixed height of 100. You'll notice there our red container appearing in the app running in the Android emulator. And what we're going to do now is remove the width and the height. And you'll notice how the container widget automatically fills all of the space available, both the width and the height match the width and the height of the scaffold body. Now, by default, the container widget will expand to fill the width and the height of its parent, provided that the parent widget specifies constraints. In this case, the scaffold body has the width and height constraints of the size of the device, the screen size essentially. You'll notice how, if we were to wrap the container in an unconstrained box, the container disappears. That's because the container will only fill the width and the height of the parent if the parent is not unconstrained. With the unconstrained box as the parent of the container, the unconstrained box introduces essentially no constraints because it removes the constraints from the scaffold body, meaning that the container is now in an unconstrained environment. That means that the container will shrink to be as small as possible, in this case 0 by 0, because there's no width and height specified of the container. Now, the unconstrained box takes a few named parameters, namely the child widget, in this case the container. You can also specify the text direction, the alignment, and the constrained axes, if any. We'll have a look at the constrained axes named parameter there, and the constrained axes can either be horizontal or vertical. Essentially, creating a constrained axis either horizontally or vertically will introduce the parent's constraints into either the vertical or horizontal axes. To show this off, we will start off by specifying axes.horizontal, meaning that the scaffold's body horizontal constraints will be applied to the unconstrained box. You'll notice how hot reloading that will make no change because the container still has no width or height set. Because we are passing in horizontal constraints from the scaffold body into the unconstrained box, if we hard code the height of the container to be 100 high, you'll notice how the container there will fill up the entire width available, and it will only be 100 high. That's because the unconstrained box still relies on the constraints on the horizontal axes of its parent, in this case the scaffold body. And because the container by default will fill all of the width available if the width is constrained, which it now is, you'll notice how the container therefore fills up the entire width of the scaffold body. Specifying the height of 100 is needed because the height is still unconstrained, because we've only constrained the horizontal axes. We change the axes.horizontal to be axes.vertical. You'll notice the container once again disappearing because the width is unspecified inside the container, meaning that because the width is unconstrained, the container will shrink to be as small as possible, given that it has no hard-coded width. If you were to change that height to a width of 100, you'll notice there how the scaffold becomes 100 wide and fills up the height of the scaffold body. Much the same as when the horizontal axis was constrained. In this example here, you'll notice how we are using the vertical constraints of the parent of the unconstrained box That's the vertical constraints of the scaffold body, and that means that the container now has a constrained vertical axis, hence why, when no height is specified, the container will fill the entire height of the scaffold body. Specifying that hard-coded width of 100 pixels is required because the container is only constrained by the vertical axes. I hope you found this useful. Essentially, the unconstrained box allows you to remove any and all constraints that may be provided by a parent widget, in this case the scaffold body, and it means that the child of the unconstrained box is allowed to flow and grow and shrink to whatever width and height is available to it, without relying on any of the constraints of the parent widget. As I say, I hope you found this useful. Thank you very much for watching.